All right, can everybody see my screen?
Yep. Yeah.
All right, thanks. So I'm going to talk about Git and what it is, and common commands that people use. Like Git calls them the porcelain commands, or they're more the user-friendly commands that people use. And there's a book that's titled Pro Git. It's actually publicly, freely available. It's a press publisher. And it's very good. And I'm only going to talk about a very small subsection, of this book, basically. But I've taken a bunch of diagrams and, information from this book. So I read this book in its entirety, and it was absolutely worth it. So what is Git? Well, it is a version control system. And it is a specific type of version control system called a distributed version control system. There's many different version control systems out there. There's a whole history of version control systems. And Git is a recent invention. It was created in 2005 by Linus Torvalds, and he created it to version the Linux kernel. And he did that because they had a licensing issue basically with the previous version control system. I think it was called BitKeeper or something. And so one of the main hallmarks of Git is that it's a distributed version control system. And what that means is that basically everyone who's, has the project downloaded has their own complete copy of the project. And so everybody else could lose their copy of the project, and you could still restore the project from that one, person who had cloned it, basically. So distributed means that everybody has their own independent, fully functional copy of the project. And there's other version control systems that are centralized, like Subversion and Perforce. And in that instance, you're much, much more dependent on the server, the main server that everybody is, communicating with. So that's what it means to be distributed, is that everybody has their own fully functional, independent copy of the particular repository. And it's very distinct from centralized version control systems, where everybody doesn't have necessarily a full copy, and they have to really communicate with the central server to really get, make commits and things like that. This diagram on the right here is just showing how basically everyone has their own fully functional copy of the project, and they have all the versions of the project, etc. They have their own version database of the project locally on their computer. And there's a lot of advantages of that. One is that you can do a lot of work without a network connection. So you could be on an airplane and say you didn't have Wi-Fi or whatever. You could still work on your project locally with a distributed version control system. That wouldn't be possible with a centralized version control system, because you would need to connect to the server to make a commit, for example. And another advantage of a distributed version control system is that things are really quick and fast, because you're not dependent on a network connection to, do a lot of things like creating branches and doing commits and things like that. So if it's local, it's going to be maximum performance. So that's one thing when people, a lot of people, when they switched to Git, they were just amazed how quickly they were able to create branches and things like that. Because, other systems, previous systems, creating a branch involved basically duplicating, all the files, and, it could take hours. Like, I know I've worked for companies where they were using Subversion, and to create a branch would take, it could take an hour, because they were storing all their images and binary data in Subversion, and it was basically insane. So Git is well known for being very quick, very fast, very responsive, and it's extremely popular for, some of those, for a lot of those reasons. Questions?
Not yet.
All right. So, I was going to open up my terminal and increase the font size because I know this is going to be too small. I forgot to do this before the presentation. All right. So basic commands. So the way Git works is it has really subcommands. And so you would type Git, Git is the command line tool, right? It's just a command line application written in C, right? And then you would do some subcommand like status or add or commit or push, etc. So there's tons of different subcommands. I have Z shell completion on my subcommands in Git. So I'm just going to go through some of these subcommands in this presentation. So git init, what that does is it creates a directory in whatever directory you're in called .git. And the .git directory has everything that Git knows about your project, everything. So that means if you delete the .git directory, that means all your version control information is gone. And that's pretty useful because you can very easily see, for example, how much space Git is taking up in your project. And in this project, this is one of my projects that I've worked on and presented on. I'm using 13 megabytes for Git, my Git, tracking. And, if I deleted this .git directory, which I have here, and it's a dot directory because that's just a Unix convention for hidden directories. So if you open this directory up in Finder or something, you wouldn't see .git, right? Because it's a hidden directory. That's just the convention on Unix-based systems. But anyways, if I deleted this .git directory, what that means is that Git doesn't know anything about this project. And so if I run Git commands, it's basically going to fail. So I can go to my desktop and I can do Git status. It says not a Git repository or any of the parent directories .git. So that just shows you that everything is in that .git directory. So yeah, and actually the .git directory holds a copy of every single file in your project at every single revision. So what that means is that directory can get pretty big, especially if you have binary files and you're versioning binary files like images, movies. Git is really not designed for that. Git is created to version source code, right? It was created by Linus Torvalds to version his C and other, source code for the Linux kernel. So it's not really designed to manage binary files. And there's one of the problems with the binary files is that .git directory starts to balloon in size because it keeps a complete copy of every single, version of whatever file. So anyways, I'm going to talk about the differences between the tracking and the staging areas. And that's very important to understand Git. Questions?
I have a question on that git remove command here.
Yeah.
Sometimes when I'm removing a file, probably using it wrong, but I'll do rm file.
Yeah.
And then then git has to do git rm file.
Yeah, I'll talk about the difference for that. Yeah. But yeah, so in order to talk about this command, I need to talk about what the difference is between tracking and staging. And basically, they're different kind of cycles or stages or whatever you want to call it in your project. And really everything starts out as untracked. And what that means is Git is not watching your file. This diagram is taken from the book reference. So if a file is untracked, that means that Git is not watching it, right? It doesn't version it. It's just, it knows that that file is there, but it's not going to watch it for changes, okay? Then when you start tracking a file, then it moves into the tracking area, which is also called the working tree in the Git documentation. And that means Git is actively watching the file for changes, but it will not be included in any commit that you make. And so the staging area, however, is what all the files that are going to be included in your next commit, basically. And so once you have staged changes for a particular commit, then you would make the commit, and then that would bring you back to the basically tracking your files back into the tracking area. And you can also untrack files, and that means you stop Git from watching files, right? And so that's what, can you see my pointer? I'm not sure.
Yeah, we can see it.
Yeah, so when you untrack a file, that means you're removing it from Git. You're saying, there's this file here, I don't want you to care about it anymore. I don't want you to inspect it and version it, basically. So that's what it means to untrack. And that can, sometimes you want to untrack a file because you don't care about that file for versioning, and so you want to untrack it, right? You don't want Git to be watching it for a lot of different reasons. Common reasons would be like, oh, I don't know, node modules directory, which is a directory that should pretty much always be ignored because it just contains library code and it's huge, and basically it will make your Git commit history incredibly hard to read whenever you change dependencies, etc. So untracking is something that people do, tracking is something that people do, and then staging and committing. Those are the basic things that are going to be done. So you have to understand what the different areas of Git are. So there's the working directory, which is also basically the tracking. There's the staging area. And then there's the commit, which brings files out of the staging area and back to the tracking or working directory. And basically what happens, oh, another thing is Git calls the staging area the index in documentation. And basically what happens whenever you make a commit, what this arrow here for commit is showing is that whenever you make a commit, you are basically writing data into the .git directory. And so that's kind of what that arrow is pointing at, is that you're taking your changes and you're basically making them permanent. Or not permanent necessarily, but that's you're writing your changes into .git directory. That's what's happening when you commit. So now that I talked about tracking staging, is this command here. When you do git rm --cache, this is 2 dashes actually, -r, what that is basically doing is untracking or removing a file from tracking. And so it doesn't mean deleting the file from your disk or storage. It just means Git it's stopping the tracking of that file or versioning, but that local copy still exists. And so that basically means Git is ignoring changes in that file at this point. So I'm going to talk about different other options that you can do to git rm. And what those do, because there's all these different, options to, for example, remove a file, to unstage a file, to untrack a file, to delete a file, and basically stage that change, etc. So Git is very reliant on the command line options to modify its behavior. Questions?
Yeah, so if I didn't use the cached option here, is git rm saying both remove it from, so
Yes.
actually into the disk as well.
Yes, it will delete it from your basically operating system, and that change will be included in your history whenever you commit.
Gotcha. Yeah, I get the remove and the git remove mixed up. So I'll often remove a file first and then
Right.
it will track it. So I have to
Then you
use
pull again and it replaces the file.
Exactly.
Yeah,
Now,
GitRM, it does the operating system delete, and it includes that, change basically. So it's convenient.
Does the RM cache, does that remove historical files? Like if I accidentally committed a passwords file or something?
No, basically what happens is when you untrack it is that Git just marks that file as being untracked, and that's part of your commit, but your past commits you still have a copy of that file in your history, right? And so in order for you to completely delete that file from your history, you would have to do some more involved things that I can talk about that's more advanced. Basically, you have to loop through all your commits, starting with the first commit that introduced that file, and you have to rewrite all your commits from that point on.
Oh, wow. Oh,
Yeah, so it's involved. And the reason I can talk about this, see, now we're going into more advanced stuff, but the reason for that is that whenever Git makes a commit, its SHA-1 identifier is based on part of that is based on the previous commit. And so that's included. So anytime you change a commit way back in history, that's going to affect all the subsequent commits. And all of those are going to have to get rewritten, because part of the commit information in the database is the previous commit. So if any commit in the history changes, now all the subsequent commits have to be changed, which is kind of annoying, to be honest, but that's the way they have Git working.
So don't accidentally commit something that should never be committed, like passwords file.
Yeah, especially, I mean, if it's your own project, who cares, right? But
Right.
if you're sharing that project with other people, that can be problematic, because if you rewrite your history, now everybody else has to go and rewrite their history.
Yep.
to match up with what you did. And if everybody's okay with rewriting all their histories, sure. You just do a git reset hard.
I think I have it on a project I was working at once at work, and thankfully it wasn't too far back in history, but if I recall, we ended up just going back to that commit, taking the file out, and then squashing all the commits that came after it.
Yeah.
And just pushing that up.
Yep. Yeah, that's what happens. That's all because Git bases its commit, its identifier, it's on the previous commit. So as soon as you go back into history, you just affected all the later commits. And then you got to push force it to the repository remote, because you changed history. And then everybody else has to reset hard, so that they basically saying, I acknowledge that I'm going to be losing all my local changes.
That might not guarantee a file is gone, because the objects are not really deleted until you do like this clean optimization of if you delete the reference to the object.
Yeah.
This,
Still be in the
and then that Git object storage, it could still keep the file. So you have to, I mean, I mean, I didn't have a factor scenario, but by mistake you do add everything, and it was yes, so some kind of binary tool was there, and it's like, okay, 90 megs I committed to the server. I don't want it there because everybody needs to download it now. So and to clean that up, you have to go depend on your GitHub or GitLab. You can, after you delete it in your commits, you still need to do this optimization on the backend to actually remove the file from it.
Yeah. Yeah, you're right. So Git has it has several things. One of it is a ref log. And so you can actually, even if you've reset hard, you can get back some of your information because it's in this log, and it will carry around old objects. I can talk about it. So in the .git directory, in the objects directory, this is where all the different files and all the different versions of your file live. And even if you reset hard, those old copies will still be here until you tell Git basically to garbage collect. There's a command called git gc, and it basically goes through and deletes all your orphaned objects and things like that. So in that case, that would be, you would lose those basically orphaned objects. So yeah, you can get back information for a certain amount of time, even if you have reset hard and things like that. So yeah, so this
Yeah. Back to your,
what?
I'll let you get back to your slides. That took us on a bit of a tangent.
Yeah, no, that was good. I mean, we just went like from beginner to advanced real quick there. So that was, I mean, that's interesting.
There's no beginner level with Git. I think how many things they want to be a beginner, just use a different tool. You get into advanced stuff pretty fast.
Yeah, you do. Yeah. Yes. So the command git add is very simple, and what it does is it takes whatever file or directory you give as arguments and tracks and stages those changes by default. So you can make a change, you run git add on the file or directory that contains that file, and you will track and stage all of those changes. There is the -N option to git add, and what that does is it tracks, but it does not stage. So a lot of people don't know about that. So those operations are independent, but by default, the git add subcommand rolls combines those. And so once those changes are in the staging area, that means it's going to be included. All those changes are going to be included in your next commit. And the real reason, from my perspective, why Git separates tracking and staging is that it's very beneficial to make a bunch of changes, but only select a subset of those changes for your commit, right? Because, a lot of times you would make a bunch of changes and, you just want to, have some of them included in this particular commit that you make. And then at some later point, you're going to include the other changes in some other commit. So I can demonstrate some things. So I'm going to create a directory called test. So make sure I don't use anything, my own customized stuff. So git init, that's just going to create an empty Git repository in the .git directory, right? Because that's where everything lives. And then I can just create a file called test file. Just give it some content. Now at this point, the file is untracked, right? Because Git is not watching it, and it's not going to do anything with that file. It sees the file is in the directory, but it's not versioning the file because it's untracked. So to track the file, I would do git add -N in the file. That's going to track, but not stage. If I remove the -N, like most people do, that means I'm going to track and stage my change. So I'm just going to track it. Now I see Git is saying changes not staged for commit, right? So I have a change in the tracking area, but it's not staged. So I'm going to stage it like this. Hit add test file. Now I'm basically just running git status, right? So now git is saying that I have staged a change. I created a new file called test file. I still have not committed my change, but I have something in the staging area. So then I can say git commit and put in a message like this file, whatever. And now I've made a commit. So now the file is back in the tracking area, but there's no changes to the file. So git is saying nothing to commit. The working tree, which is synonymous with the tracking area, is clean, right? So that means there's no changes in any tracked files. So I just demonstrated git add and git init.
So what's the point of tracking untracked files, just tracking alone without, staging or doing anything else?
Tracking, well, I don't know. Maybe you wanted to track a file, but you don't want to include it in your commit at this point. So then you would just track it.
Why would you track the file just to track it? Like, okay, there's an untracked file in the repo.
Most people do not. They directly go git add in the file. So that would stage, track, and stage.
Yeah.
So that's the general workflow. It's just that git allows you to track but not stage.
If I created a file that was tracked but not staged, and then I did like a git pull, or I cloned that repository, would it create an empty file with that name?
It will not overwrite your current file. So your changes will be there just on top of whatever git has seen for the file, I think. Like if you had modified the file, right, it's going to show, git's going to show your diff of your mod changes.
Right. Just wondering if it would be similar to just a touch command that would create the file, even though you don't.
No, I can see maybe like if you do some kind of git flow automation or something, and you want like stuff to be very specific, like yes, I'm tracking it, but not staging, kind of, just to affect the status of that file when you run something. But if I'm honestly, I have not known that -n sign. I've been using Git for quite a while, I'd say.
Yeah, a lot of people don't. It's not a common thing that people do.
It does separate your unstaged and untracked files. So if you don't want your actual code to be included yet, but it annoys you that it's separated, because that always annoys me.
I'm trying to see, like, if you try to do something like some kind of scripting around Git, and you want to do the status like porcelain or something, just like you can do machine logic, kind of in your script on top of it. If that would affect it, like in one, it's like, oh no, you have changes. In the other case, it's maybe with untracked file, it's like, well, I don't care about it. I'm not tracking it.
Right.
I mean, that's what I'm saying. I can only see like if you do some kind of scripting around the Git flow, that could be interesting. Need to try.
What would happen if the file was untracked on one branch, but that same file is tracked on another branch, and you go between the branches? I guess if you go to the one that's untracked and you add the file, and then you go to the branch where it is tracked, it would replace that file. That's I'm guessing.
Yeah, I think it would. Yeah. Yeah, there's all these scenarios you can try. It's the git ref log. I guess I can talk about that, but the git has a subcommand called reflog, and even if you have reset hard or done something destructive, you can cherry pick commits and stuff out of the reflog. Well, that's basically, you know, when we were talking about before with the kind of cache local history of commits and stuff that you can cherry pick out of this. And Git cherry pick is a way to basically just take individual commits and replay them on top of your current commit. So, all right. So I talked about how to untrack a file, and that is git rm dash dash cache dash r. And
I couldn't figure out exactly what that was
and then git rm, that's going to delete the file and basically include that in your next commit. And if you wanted to, oh, I already talked about this, git rm dash dash cache is untracking a file, removing it from the tracking, but you still have a local copy of the file. So the subcommand git commit, the commit subcommand for git, that is writing your changes that are in the staging area or the index into that .git directory. And so this is a very commonly used subcommand. And Git requires you to have a commit message. If you try to have an empty commit message, Git will abort the commit. And the commit message is very important. A lot of people have different conventions on how you're supposed to write commit messages. Like a lot of the companies I've worked for, it's all you have to include your story number in your commit. So you do like git commit dash m, you know, whatever, some prefix and then a number and then dash and then my message and stuff like that. And these type of commit messages are very important because it allows your project management tool like Jira or others to link up your commit with the story or bug you're working on. So when you do git commit dash m, and then generally you want to put your commit message in quotes, either single or double quotes, and that's just a shell thing because you don't want the shell to interpret any of these characters in here as, you know, outside of, you don't want the shell to manipulate those. So generally single quotes are the hardest style of quoting in the shell world. So I'd recommend single over double. But yeah, so if you do not include the dash m option, then Git will open up your editor that you specified in your editor environment variable, and then you will type your commit message there. And you can also do the -am option, and that means I'm going to add, it's basically you're doing git add and then git commit all in one. And so you're basically adding all the files that are in your present working directory to your commit. So that's essentially skipping the staging area. And you can also, we talked about what happens when you need to rewrite your Git history, and it gets very tricky and pretty rough when you go super far back in your history. But if you're just redoing your last commit, it's very easy, especially if you have not pushed your last commit. You can just do git commit dash dash amends, and it's basically you can redo your last commit. So it's very easy to redo your last commit. In fact, I do it all the time. I actually run this command I rerun all the time. I do. All right, so say I had a, you know, I created this test file, okay? Say I needed to add some more stuff here, whatever. So now I have modified this file, I'm tracking, you see I have not staged these changes, blah, blah, blah. But maybe I just wanted to include these changes in my last commit. So this is what I run: git commit dash dash verbose dash dash all dash dash no edit dash dash amend. And basically that's just going to rewrite my last commit and include all my changes that are currently present in this commit. And as long as I haven't push forced it, nobody's going to know the difference. As long as I haven't pushed it, nobody, it doesn't affect anybody else. So I do that, and now I have a new commit. It's the same name, same message as the previous commit, but the SHA-1 identifier will be different because that's based on the file contents, for one. And so now I just basically amended my commit, and yeah, it was, I run this command all the time because I, make some little change and I just want to include that in my last commit. I don't want to create a whole new commit just based on some little trivial thing. So
what does the no edit flag do?
the no edit flag means don't open up my editor to reword my commit message. So if you remove that, now Git's going to open up my editor and say, do you want to change your commit message or keep it, right?
Mhm.
And generally, I don't care. I want to keep my message, my commit message. So I say no edit. And -- verbose is optional. It just gives you more information. And I believe -- all does, it just includes all your changes, I believe. Let me see. I have Z shell completion here. Yeah, so git commit dash all will just stage all changes. So
Does that work with any commit? If I do like git commit dash all, it'll take anything that's unstaged.
Yeah, that'll be a get
yeah,
add,
yeah,
A, and then a get commit.
Yeah.
Sure.
yeah. This this will include all your tracked and all your changes, and will rewrite your last commit to include all your changes. So I run this like all the time because this is a common thing. Now, as soon as you do this, now you have to push force. If you had, I talk about remotes and stuff like that, but if you had previously pushed this commit, you did this git commit -- amends, you're now going to have to push force to your remote branch, right?
What's the difference between push and a push force?
A push does not allow you to rewrite old commits. You can only add new commits. A push force allows you to do anything.
You're basically rewriting history.
Yeah, you're rewriting history, and that's basically as soon as you push force, everybody else who's working on the project has to reset hard because their changes are not compatible with your changes anymore. So that's anytime you see force -- force or -- hard in Git, that means basically you are potentially deleting history, right? You're potentially losing information. So if you did a git push, so say I ran this command up here, these two commands, now everybody else is going to have to do this on their local git reset hard, because otherwise they have the history changes in their local, and then you have push forced a new history to the server, and that new history is not compatible with their local history. So now
What if you don't do hard? What if you just do git reset? Wouldn't it just get your current history into your local and then tell you what your difference with the local files would be?
well, yeah. I mean, yeah, you'd have to like basically reconcile all the differences manually. So the reset hard just says, just give me whatever's in the remote. I don't care. Like
Yeah.
if you're, if everybody's working on a project and somebody push forces, that basically means if you start to, and somebody else comes in with their local and they're going to have to reconcile the differences, and now they're going to get a completely different history now. So you're basically diverging the histories, and now everybody who wants to work together on this project is going to have to reconcile manually, like, you know, merging all the different changes, and everybody's going to get different histories. So that's the problem with push forcing in general, is that you're changing history, and then now everybody's going to have different histories, and they're going to be out of sync, and then you can manually merge things and stuff like that. But then you're just creating all these merge commits, and and then you push your changes, and then the person who pushed force, now they're going to pull, and now they're going to have all these conflicts and stuff like that, because everybody's history is out of sync, right? Because you rewrote history, and now their local history is not compatible with your history, right? I mean, that's a distributed version control. Everybody has their own history of the project. So that's why rewriting history is dangerous and annoying, basically. That's why everybody says with Git, don't push force, because that's dangerous. Now everybody's going to have all these merge conflicts and blah, 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 right? So anyways, kind of derailing here because I don't know, just kind of the way it's been going. But yeah, so Git, it tends to hide all the dangerous stuff behind different options like --force and --hard. So if you don't include those options, a lot of different subcommands, generally you're not going to lose any information, stuff like that. So all right. So if you're confused about Git has a help subcommand, and then you can type in another subcommand like add and stuff like that. And that's essentially the same as man git-add. So all the man pages are for Git are like git dash and then your subcommands like push or something like that. So Git has a lot of different man pages available. And in the documentation, anytime you see index, that's basically staging area. There's synonymous, and working tree is tracking area. So there's just some synonymous. Working directory is synonymous. Working tree, really. So yeah, and you can go through this documentation and see all the different options. Like here, the -N option, a lot of people don't know about, only tracking the file without putting it in the index, really. Intent to add is the long option. Record only the fact that the path will be added later to the index, showing the unstaged content of the file with git diff and committing them later. So it's basically saying you might want to use -N if you just want to document the fact that you want to stage something at a later point. I don't know. Yeah, so the git ignore files really is very, very important. There's a whole hierarchy of git ignore files, and the git ignore file is a file that contains a list, really, of all the files you want Git to ignore, right? And actually it can be files or directories. So if it ends with a slash, it's a directory. That's just a Unix convention for directory separation is slash, right? /. The pounds, hash signs are comments, and you can do basic file globbing. So a star means any character, any number of any character, right? So say you wanted to ignore all IML files, .iml files, that's star.iml. An IML file is an IntelliJ modules list. So that's IntelliJ is a IDE by a company called JetBrains, and they store modules in this file. And so that's an IDE specific file. So generally people ignore IDE specific files because, well, what if somebody's using a different IDE? It's no longer relevant. What if somebody's using the IDE, but they have different settings? Do you really want them to get your local settings and have everybody having conflicting settings? I don't think so. So generally people ignore IDE files, integrated development editor files. And people also ignore library files because why would you want to version library files? You could just re-download them, right? And generally people ignore operating system files. So why would you want to version something that's part of the operating system that's not related to the project? That doesn't make much sense. So a lot of these .ds store files, those are Mac OS, like basically Finder files, desktop services, store files that just like store information for Finder app, which is just a file browser app, and other things. Spotlight V100 is V100 is for Mac OS, the Spotlight indexing. Spotlight is their global search, right? And things like thumbcb is a Windows file that stores thumbnails, cache, blah, 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 blah. So yeah, that's the node modules. I mean, that's the gitignore file. And there's a global gitignore file, which you can specify, which is in your home directory usually. But there's also a local gitignore file in your project. So a lot of people create a .gitignore in their project, because what that means is that everybody who clones down this project will automatically download this .gitignore. So that means it's very convenient that people don't have to set up anything outside of this project for their gitignore. And there's actually a third file that Git uses to ignore things, and forgot where that is. I think it's inside the .git directory. Gitignore file. It's just there's another one. Oh, git info exclude. That's it. Git info exclude. So this file, a lot of people don't know about this probably. This is another file that you can list, ignored files in here. And this is not, so the gitignore global is global to all your projects. The .gitignore in your local repo is only local to the project, but it's also versioned. And then this git info exclude is local to the project, but it's not versioned. So I don't know if people usually don't use that one, but it's there. So that's, there's basically three files that Git is watching for the gitignores. And yeah, questions?
I think gitignore you can have a gitignore file in any directory and it will always ignore from that, or
Point down.
it'll ignore files that are relative paths to that file.
Yeah.
So you will get ignored as a project.
Yeah, most people put it in the root of their project, but you're saying that you can put it in various subdirectories and it will just ignore from that subdirectory down, right?
I believe so, yes.
Yeah, so yeah, I mean, Git has a whole hierarchy. It's got a precedence hierarchy where it's gonna look basically up the file tree for gitignores, and yeah, you can modify it in some nested directory. Yeah, there's a lot you can do with gitignores, and that's extremely important because you don't want to be versioning. You want Git to version files that you want it to version and nothing else. So, like secrets, any file containing passwords, usernames, passwords, things like that, generally you absolutely do not want to version, because as soon as you do that, now you've got them all throughout the Git history. And so you got passwords all throughout the Git history. Everybody knows the password because they can just look through the history. And it's very bad, very insecure. So history and password secrets and passwords configurations is another thing, environment variables, things like that. Generally, you don't want that in your project for a lot of different reasons. And one of them is, if you go into deploying to different environments, you don't want that basically hard coded in there. You want that to be more flexible. So anyways, git ignore is extremely important.
I can share a trick with git ignore I'm using.
Yeah.
Because Git would not track, directories, folders, whatever you call them. So that's why a lot of, I guess, if we have beginners, probably would wonder why would you create folder? I think the later versions now they track it natively, right? Or no?
You're talking about git keeps?
Yeah. So Git keeps.
Yeah.
And so,
If you create a directory, Git is not going to track it because there's nothing in it.
Yeah.
So a lot of people create a file called keep. Sorry.
Well, you can call it whatever. Like Git keep
Yeah,
usually create it in GitLab. At least you create, it will put that file for you.
Yeah.
But again, you don't really kind of want that file. So if I want to create a directory structure, like kind of boilerplate project, I would put git keeps, then I'll tell git ignore those git keeps, and I forcefully add it, even though the git ignores you can force it to add that file anyways. So whenever developer checks out, the folders are there, the files are there, but whenever he's adding his own files to the structure, those git keep files, he can delete it, or keep it in there. So Git is not really tracking those files from that point, or whatever happens to those.
It staged the folders, and then you add the folders to the history, but you're not committing the keep files.
No, you commit the keep file forcefully the first time, because in your git ignore, you ignore the git keeps. So later on, when I go to the folder and let's say I delete that git keep file, the Git is not complaining to me like, oh, now your file was removed. Because I don't care what happens to that file.
You added it, you committed it, but then you would add it.
And then I'm ignoring, like I committed once and then I ignore whatever happens to it later. Because a lot of times like you would copy paste like content of a folder from a different place, or like you just you don't want that stuff on telling you like, oh,
right. That you might want file structure because a shell script depends on it or something.
I mean just to give people places to put things.
I see you use a lot for test folders. If you're using a framework and has a test folder, there might not be anything in it yet. Like you just created the project, but they want you to use it, so they put the
you have to
be test folder in there.
Yeah.
GitHub, I noticed I've used this before. They have a git ignores repo it just has a laundry list of git ignore files for different projects and languages.
Yeah, if you create a project in GitHub, you can tell it to create a git ignore and select the language you're using through GitHub, but also somebody has created a git ignore repo on GitHub. Yeah, he's looking at it there.
Yeah.
Yeah. So GitHub has its own repo called git ignore, and it has a whole variety of different git ignore files that would be useful for a particular language or framework or build tool or whatever. So I've my own personal git ignore that I've developed that I just use in general, like my global one. I've taken snippets from all of these. So yeah, not all of these, just whatever.
IDEs are kind of like like if in your team you use the same tools, it's fine. But let's say everybody who is gonna work on a project and start adding their ignores for their own IDEs. Now you're gonna have a whole history of git ignore separately developing. So probably those folders and files should go into the kind of like your, kind of a either environment like global stuff or
There's
they
a,
exclude
if you go
one.
into the Git directory, there's an excludes file.
Yeah, and
Yeah,
it excludes
Yeah,
kind of
you just
probably.
you add it there, and then Git doesn't know about it, and it's specific to your machine.
Yeah. The Git ignore kind of, it's a good place to put stuff, but not personal stuff, I would say. Yeah.
Yeah, for personal stuff, you would put it like get info exclude if you don't want it to be global. And then if you wanted it to be global, that Git has a configuration actually called core.excludes file, and that points to your global one. That's global to all your projects and is not version controlled. So you can change that actually to whatever file you want it to be. So what is a Git remote? A Git remote is a server, right? It's, GitHub. What is GitHub? It is a Git hosting platform. That's it. Really, there's tons of different Git hosting platforms, and Git refers to these servers as remotes. And it actually doesn't have to be a server and stuff like that, but that's generally what it is. So if you do git remote add, and then you put in the name of the remote, and the default name is origin, but it doesn't have to be origin. It can be anything. And then after that, you put in the URL to the remote. So generally, I'd recommend putting quotes. I don't know why this is just when I copy and paste it. But I put quotes around your remote just to stop the shell from doing stuff. But you can have a whole variety of different protocols for remotes. So there's HTTPS. That's a very common protocol for remotes. But there's also SSH. You can use SSH protocol to connect to your remote. And there's benefits and drawbacks to each one of those. Most people are using HTTPS. But there can be benefits using SSH. And when you do git remote show origin, that's just going to give you information on your remote. So let me go to the directory. And it's just going to give you information like the URL that's being used for fetching. Fetching is when you're basically downloading the latest information about your project. Pushing, where you're pushing your changes to. So in this case, these URLs are the same, but you could be fetching and pushing to different URLs. It's not normally what happens. Head branch means Git has the concept of head, and head really is just a pointer to the latest commit on your current branch. It's really what it is. And so head branch, just saying I'm on the master branch. Remote branches, this is talking about what branches are there on the remote, like available, and then what branches are there locally. And those, because Git is a distributed version control, those can be completely different, right? You can have local branches that you've created that you have not pushed to the remote. So, there could be remote branches that somebody else has pushed, but you have not gotten yet. So that in that case, there would be a remote branch, but it would not be local. And there's also with Git, you have to link up your local to the remote branch. Basically, for each branch, you have to say which this local branch dev, which branch is it going to be by default pushing to on the remote. So in this case, it's dev, but you could push a branch that's named something else to something else on the remote. So these names do not have to be the same. So, but Git has to link up all your local stuff with the remote stuff, and because it's a distributed version control, your local hit project and the remote project can be completely, different. They shouldn't be. in general, they should be all synced up. That's the whole point of Git, is that everybody can work together and sync up their local with the remote. But sometimes that, it's not the case. And if you do git remote -v, that's just going to list out your remotes. So a very common thing, let me go to the Z shell project. I've contributed to Z shell. It's a very common shell. So if I do git remote -v or -- for both, this is saying that I have two remotes. I have origin and I have upstream. And this is a very common thing. So I have forked the Z shell code, right? The Z shell code is at SourceForge. Okay, that's where it's hosted. So SourceForge is another Git hosting protocol, platform, sorry, like a GitHub. And the Z shell developers, they choose to host their code at SourceForge. Okay, mostly for historical reasons. And actually, I didn't talk about it, but they're using the Git protocol. That's a third protocol that you can use to access your remote. I forgot to mention that. And this remote that I have is called upstream. And so I've created a fork that lives at this URL on GitHub, and that's called origin. So I have two remotes. Origin is my fork, and upstream is the original, like the main line or the trunk code, right? So I can, pull or push from either of these remotes. It all generally, when people fork something, forking means that you're taking somebody's project and you're making a copy, really. So that's generally done so that you wanted to fix something in the main project until you create a fork, and then you make your change, and then you would make a pull request back into the main project. So here on this repository, I could fork it like this, and now I'm going to get my own repository in GitHub, and I could make changes here, and then I could make a pull request back to the original, which would probably be called upstream, and then they could merge in, my changes and stuff like that if they wanted to. So, right here you see there's a lot of different pull requests here and stuff like that. So a lot of this is just communication on changes that have been proposed. But basically, a remote can be named anything, but a lot of people have origin and upstream as common names. And it essentially is usually a server that's hosting your code over some network connection, right? And you can rename your remotes, you can remove them, create them and stuff like that. And whenever you're doing subcommands, a lot of times I do this. I fetch all the changes, and then I pull in the changes. I'll just write everything out. I pull in the changes from my upstream, and then, well, in this case, it's up to date, but now I'm going to push. So I pulled in the changes from the remote called upstream, and now I push all those changes to the remote called origin, master branch. And so basically I've just updated my local or my fork with all the changes from upstream. That just keeps my fork basically up to date with the core, the trunk, the main project, right? Questions?
Nope.
All right, so git push. Git push is a very common, subcommand, because a lot of times you're working on a project with other people and you want to essentially publish your changes. So because Git is a distributed version control, you can do all this crazy stuff on your local project, in your local history, and nobody else is going to see it until you push your changes, right? So it's basically like publishing your changes to the trunk or core or mainline or whatever, There's a bunch of different words you could use to it, but it's, the main remote, in general, conventionally called origin. And there's a lot of different ways you can do git push. When you just type git push, so say I'm in a project and you just type git push. Well, that doesn't really explicitly tell me much, because whenever you're doing git push, you have to know, first of all, what remote am I pushing to? Because you could have hundreds of different servers, right? So you need to link that up, first of all. And then even after you have specified the remote, you also have to specify the branch, because you could be pushing any branch to any branch on the remote, right? You don't know, you have to specify that explicitly at some point in time, or Git can set it up for you automatically. But I can talk about that. So git push origin master, that means I am pushing, actually I can specify even more explicitly. So I can do this, git push origin master : master. So what that means is I can rename this. I can call this local and I can call this remote. So what that means is I'm going to take this local branch called local, and I'm going to push that to my remote called origin, to a branch called remote, right? So basically what that means is I can have my local branch named anything, and I can push it to any branch with whatever name I wanted to. So the names do not have to, the names of the branches, local, remote, do not have to match up. So I probably should do some more examples, but basically to create the linkage, if you just want to type git push, you have to set up the linkage of the remote and the branch. So the way you do that is you do git push -- set upstream. Okay, that's also, there's the -u option. This is short form. And then whenever you do that, then you specify the remote name and then the current branch that you're on. And so that's going to set up the linkage for Git. The pointer is really to allow you to do git push from now on. And now, because git push is really just shorthand, because you're not specifying the remote, you're not specifying the branch. So whenever you do git push now, after you have run the set upstream, now it's going to basically say, okay, well, I've seen that you want origin as your remote, and I've seen that you want master as your remote branch. So I'm just going to push the current branch to origin master, right? That's what Git is going to do, because it says, oh, okay, you set up these defaults, etc. And let's see, Git, what was this previous? Oh, show origin. And Git stores all these linkages actually in the .git directory. If you go into here and you go into refs, you go into remotes, origin, ed, remotes. Basically, there's separate files inside this .git directory, and that's the way Git stores those linkages, is it just creates files that point to basically other files that have, that represent branches and stuff like that on different remotes. So yeah, so if you wanted, so say you made some change locally, and you basically rewrote history, like you amended a commit, or you rewrote history in some other way, you did maybe a rebase. And so if you wanted to now publish those changes, well, you've changed history. So now that means everybody else who's using that history is going to be affected. So Git requires you to pass the -- forcer -f option. And that's going to enable you to override the remote history. So you can see here, if you don't have the -F option, Git is going to say, well, this remote has a different history. It has commits that you do not have locally. So you could either try to git pull and pull in all those remote changes before pushing. You could do that. But in this case, because I was just rewriting history, I just wanted to overwrite the remote. And now what happens now is everybody else who's working on the project, whenever they do git pull, they're basically, or whenever they try to get pushed, they're gonna get this message, and they're gonna have to try and merge in all your changes from the remote into their local history. And then things are gonna get messy, because then they're gonna push their changes, and then you're gonna have to try to integrate their changes and blah, 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 blah. So anyways, it's, rewriting history is difficult and not something you really want to get into much with Git. Just not designed for that. So another common subcommand is git diff. And so diffs are really, diff is just short for difference, right? It's going to show you the differences between a lot of there's different ways you can configure it. But by default, when you just do git diff, it's just going to say you unstaged files. So basically what you would be adding with git add. And then if you do git diff -- stage, it's going to show you all your stage changes. So git diff is really your track changes, and git diff -- stage is your stage changes. If we go back to the tracking and staging, areas concept. Yeah, so the most common thing I do is I just do this one, git diff -w head. And so say I've done some weird stuff, like did some files or whatever, random content, and I git diff head. Well, these aren't tracked, so let me track them. So I tracked, but I did not stage these files. Now I do git diff -w head. And head, I already talked about, that's just a pointer to the last commit on your current branch. And the -w means ignore all changes in white space. And so now Git is showing me that I have two files that were added, right? And they have this content here. And so, yeah, git diff is very useful because you can see all the different changes, and there's so many different ways you can invoke this, and you can compare two different branches, and you can compare your local to the remote, and you can compare, tons of different things, stuff like this. In this case, I'm just comparing my local changes to basically the last commit. And I'm not going to go into all different ways you can do git diffs, but there are a ton of different ways, and you can compare almost anything with a diff. And this is very useful for comparing source code changes, which is something that, software developers do all the time. And there's all these different types of pretty diffs, pretty diff programs. Like I'm using diff so fancy. It's just an npm program, and you can use that to like colorize your diffs and stuff like that. So that's what I'm using. It's just an npm program, sorry, library. And yeah, so that's what I'm using here to basically colorize my diffs and stuff like that. So a git pull, what is a git pull? A git pull is actually a git fetch and a git merge. So that means I'm going to take all the changes in some server, some remote or some other, it doesn't actually have to be a server. It can be actually another directory. There's a, I mean, the most common instance is a remote that's a server that's, on some network on the internet, etc. And so you would fetch in all those changes. That means basically updating your local repository to see all the changes in the remote, and then you merge all the changes that are present on the remote into your local copy of the project, right? So Git is distributed, so local and remote can get vastly out of sync. And so Git pull is basically to resync your local with the remote. And the syntax is git pull and then the remote name, then slash, then the branch name on the remote, right? And so that's going to take all those changes on the branch, remote branch, and then merge them into your local branch, whatever branch you're on. And you can tell Git, you can specify different, remote versus local branches, etc. But that's just the default behavior. And if you see people running git pull just by itself, that just means they've already set up all the linkages between their local branch and their remote branch. And so the way you do that manually is you do git branch -u, and then you type in the remote and the branch. And that means I'm going to set up a linkage from my local master branch to the remote branch called master on the remote named origin. Now I've set up that linkage. I can just do git pull. And if you want to pull force, you can. It's basically, going to overwrite your local changes. A git pull rebase, what that's going to do is it's going to pull in. A lot of times when Git pulls in changes, you'll get a merge commit. And sometimes you don't want a merge commit. So if instead you just want to rebase the changes, and rebasing is a more advanced topic, but it basically means replaying or kind of taking some other commits and just putting them on top of some other commit. It's kind of like replaying commits, and you can rebase a bunch of commits on your commits with git pull dash rebase without any merge commit. So some people do that because they don't like all the merge commits. And I can demonstrate what a merge commit looks like. Basically, a merge commit looks like this. Merge remote tracking branch upstream /master. Right here. That's the commit message. That just means this is another forked project. So this merge commit says that I took all the changes that were in the upstream remote and put them on top of my fork. Questions?
So what do you use most of the time, rebase or merge?
I mostly use just basic merge because that's just the most common workflow. I personally Git is mostly a source code collaboration tool, to be honest. So it's a lot about communication and working as a team with other developers. And on my personal projects, I don't like merge commits at all. So I try to do everything super clean, like commit history. But a lot of people, they want those merge commits for whatever reason. I think it's noise, but a lot of people are okay with those merge commits because it makes it really obvious when you basically merge branches and stuff like that. So I don't know. I mean, the default, whenever you make a pull request on GitHub, so we can go to GitHub and go to here, this GitHub git ignore repository. Whenever there's all these PRs, whenever these get merged, okay, or if they get merged, basically in the code, you're going to see all these commits, these merge commits, and those will basically signify whenever somebody, made a pull request. And it's kind of like useful because look here, here's this number here, and then you can go and look at the pull request and stuff like that. And I don't know, it can be useful to signify when, you did a merge.
Yeah, I guess there it's when they want to merge their changes into the public repository. So technically, you merge in two different histories together to become one, right?
Yeah, I
But
mean, yeah,
when you pull to your local, I would usually do rebase because
yeah,
if I only have my commits on my local machine, nobody ever saw them.
yeah,
So and they're gonna stay. Just the hash
yeah,
will change because it will put my history on top of the remote history. I
yeah,
feel like that's kind of have
yeah,
less commits at the end. And
I've noticed that if I'm working on a project, I have a branch that's open for a long time for some reason. I like to rebase because if I do the merge and I see all this history, it could easily become untrackable because I maybe my first commits are at the bottom, then I have a merge with now
yeah,
that history, then I have some other commits on top of that, and then if you get conflicts later on, those become difficult to track.
yeah.
So,
Yeah, I have the same opinion. So when I'm like, I think in the public central repositories, those merge commits are good, but in my local, like my forks, I always get rid of all of those, and I usually just basically, I usually reset hard to the remote, like upstream master. Actually, I usually do. I haven't talked about this, but there's a get reset soft option. And this, so say I had local changes, okay? Like say I'm in some, my fork and I make some local changes, okay? So I've got some file that's staged here, but I just want to basically wipe out my commit history to the upstream, okay? So I'm basically prepping for a PR, okay? So I do this. This is just going to keep my local changes, but it's going to wipe out my commit history to the upstream master. And now I can do my commit, right? Blah, 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 blah. And then I can make my PR. So basically when I'm doing this, I'm saying I don't care about all my local commit history. You get what I'm saying? Because that
yeah,
doesn't matter. So all those merge commits, all of that, it's gone. Because I just did the get reset soft. But I'm still keeping all my local changes because if I do get reset hard, that's going to wipe out all my local changes.
but yeah, but you're gonna lose your local commits.
Well, yeah,
With
I am.
the thing around it. So that's what I'm saying. A rebase would solve for that. It will pull the remote history to your machine and just
Yeah,
put your. I mean, no, it's
Depending
You
on
have-
how your PR strategy, a lot of times when you merge in a PR, it flattens everything anyway.
it's
yeah,
cross
squash merge.
Yeah.
merge. Yeah, that's what I was going to ask. Like if a lot of projects require you to do that.
And people can argue for weeks and weeks and weeks at a time on whether you should squash and merge or not.
I mean, you gotta get all your messages in your squash. Yeah. But,
Yeah, I like, yeah, the get reset soft, that allows me to do like basically my own local squash because I wipe out my changes and then I roll them all up into some new commit message, right? My final one. Because a lot of times nobody cares about your local commits. To be honest, generally, like usually people just care about your final changes unless, it's something incredibly significant. So I usually try to roll up my changes into,
if as you showed before, if you work from tickets, somewhere, and you want those ticket numbers to be preserved in the history, then you care about about that.
Ideally, you shouldn't have more than one story in a single commit, though.
yeah.
Yeah. Well,
if you're using something like Jira to actually track to link up the commits and everything.
Yeah, but you might have like a feature branch, or you might have like, I don't know, kind of a different, like a bug fix branch,
Mhm.
and you would want kind of that history being saved there, and then when you push the code like into whatever master or main or whatever you call it, or release branch, then you might not really want those details. You just kind of
Most companies that I've worked with, I'm a consultant, so I work with a lot of different companies, and most of them have their own processes behind squashing and merging, or just merging, or having multiple commits in the same, or multiple stories in the same commit and stuff like that. Anyway, so
usually what I do in a project, I would say like a git flow txt file, and I would put all those commands the developer needs to run to check it out, to commit, to merge, to do like if whatever the flow. So it's easy to kind of, especially if you have like multiple projects, and then these kind of, oh, I forgot what I do here, and at some point we had to develop a very complicated git flows when we were pulling from like a vendor repo. But the way they structured, you pull from their repo, and then you put your own files to develop the product in between their files, and they would go and do version upgrades. So, and it's like we had to, in our repository that will just track our project, because they have like tens of thousands commit in there.
right.
So I don't want that history. I don't care about the device. So I don't care about their history developing their baseline, but the only history I care about is when they release new versions and tag them.
Mhm.
So I want to bring all the changes to a specific tag in my project with one commit, saying like, hey, I'm grading from 6.5 to 6.6, and my commits matter to me because that's where I develop my code. I want that history to be preserved. So
Right.
yeah, and
Totally
and,
depends on the context.
and
I think it totally depends on the context. Like
Yeah.
you're like building something new, and you just want to I'm working off of release 1.5.2.
Right.
Like that's cool. But if you, let's say now you have to go debug an issue with 1.5.2, it's helpful to know like how much went into that release, how many tickets
Yeah.
did that compose
And
of.
it sounds like that kind of a scenario is like developing from a white label.
Mhm.
Like somebody created a white label product and you're
Yeah.
customizing that.
yeah.
And yeah, at that point, you wouldn't care about any commits that the white label did.
But that's what I'm saying. Like you go to advanced Git pretty fast because but Git allows you in your Git repo to track a branch completely unrelated, kind of like and bring it, from remote, Git repo into your own local project. Not the files. It will bring the objects and changes, so you can fetch them into your local. Like you're not gonna see those files. And then you can, again, tell it to go and merge that stuff on top of your project. I mean, it will complain about not having a predecessor, common predecessor for your commit messages, like a commits chain. But and that's like another tip of like that taught me always start a project with an empty commit and called initial, because empty commit in Git, all the Git repositories, if it's a first commit that's empty, it will always have the same the SHA. So it becomes your kind of common, point from which you can develop totally different branches from it, like a project.
Mhm.
And then from a Git perspective, you can still merge them together because they all came out from this empty, like null commit nothingness.
Right.
So from a Git perspective, it does have a common, point somewhere back in the history. So that, I mean, like we didn't use it much, but still, like I usually just working on that one
Mhm.
made me to like whenever you have a new Git repo, just do commit empty initial, and then everything goes on top of it just for
Mhm.
I don't know, became a habit. And
Well, one thing I will say, like one of my pet peeves is when people merge in PRs with all these tiny little commits, like add test case this, add test case that, change this, change that, because not only is that a longer commit history, but it also makes the .git directory that much bigger, because every little change, every file, every change to every file is stored in .git. So you're going to make the .git directory way bigger for everybody because of all your tiny little commits that are in your PR. So I generally,
actually, it was funny. Like I used to come to Hash Rocket before, and they were doing like they were pretty big and like Git shop, right? And that was like, oh, commit like often, and just for the sake of it, like to show like you need to commit your changes often. There's like pretty much people would commit their work when they go to the bathroom. Who knows what happens to my machine?
Yeah.
Like when I come back, and maybe I wrote just this really good piece just before that, so they would just like commit like one line changes would go into commit, but then yes, you go and pick, you kind of squash them, you can redo the commit like before you show it to somebody else. On your
Yeah.
own machine, you can do like pretty much any symbol you enter, you can commit that. And
It makes sense from like a branch perspective where you might be making like small changes, and then maybe you get something reviewed. It's like, oh, let's change this, and you go back and you're making a lot of changes. Some you might keep, some you might not keep. But when you go and merge it to the the main or master branch, then you have to then those commits no longer make a lot of sense.
I kind of
irrelevant at that point.
I kind of like found myself committing, when I'm done with a certain file, and I guess it came because of like, I don't know, like GitHub does this same. We use GitLab because they change on next to the file. They're gonna show you the latest commit message affecting it, and so I kind of use it like as a visual. Like I want to know what happened to the file, the latest. So I would just do commit per file just to get that message on the UI when I look at, on a like web UI for that thing. So yeah, I don't know, like yeah, it could become granular. You would do changes multiple files, like you added like git ignore, and I would commit saying like, oh, I added this stuff to the git ignore file. So then next thing I see like, okay, so what happened? The latest change to my all the files I have, and it just shows it there. And I guess it again became this habit driven by how they build the web UI for this stuff.
Oh yeah, I mean, I would say, in my opinion, one of the shortcomings of Git is that the way that it stores changes to the files is that every little change is going to be a complete new copy of that file stored at that change. If you add one character to like a million line file, you're going to get a new file with a million and one, just that little character. So it's complete copies of every file, every change. So that .git directory can get massive.
You can merge all the objects. There's the maintenance command there. I mean, if you know for sure you're never going to need that old version, you can just purge it. And if you try to check it later, I feel like we try this. It complains about that. It does not have any, all those objects not be restored. But yeah, there are like for the big projects. I remember, having those issues.
Yeah, and like the Linux kernel, if you've ever cloned down that project, I mean, it becomes somewhat pretty unwieldy because you're dealing with source code, which you would think is, it's just C source code, but then it balloons to the point where it's gigabytes of files, and so much of that is stored in Git and all these tiny little changes to these files, and it's it becomes unwieldy at a certain point, and that's why generally people don't version control binary files like images and videos and other things, because Git is really not designed for big files.
Git, what does it do? I've seen like they're like, whether to support or not support large file, type.
Yeah, well, like GitHub doesn't, the max file you can upload, I think, is 100 megabytes and stuff like that. They have that LFS system for larger files, but it's just, I don't know, the way Git works and how it keeps tiny little changes. I mean, especially if you have big files, I mean, every little minute change, 1 byte change, one is going to create a whole nother copy of that complete file. So
I would think that maybe with the large file support, they would change this kind of packing mechanism, like, only do deltas or something like that.
yeah, I mean, I don't know, but it's just, that's the way Git was designed. And I was reading a book on why do they store every single little change as a complete new file? And the reason was because it was more reliable. There was previous version control systems where they were storing the deltas, and then something would get corrupt, and then basically you couldn't get back any files because their whole lineage was destroyed. And I don't know, it's just they made decisions with Git to make it more easy to use at the expense of other things like file storage. So anyways, a lot of decisions in the history of Git, and Git is still evolving over time, and it's interesting to see how it changes over time. Anyways, git status is another common command. It shows all your tracked and staged changes. So there's different sections. There's the changes not staged for commit, so that would be your tracking or your working tree area, and then you've got changes to be committed, which is your staging area or your index. And so whenever you do a commit, obviously everything in your staging will go in your commit, and everything in your tracking will not. And everything that's untracked, of course, that's not going to be included in your commit, because Git is ignoring, well, it's not ignoring the file, but it's just not watching it, right? It's untracked. So git status will show you those different, basically, areas that the file could be in, either untracked, tracked, or staged. And there's also a short way of displaying status. So a very common subcommand is git clone. What does git clone do? Well, it's more than downloading the project. It's downloading the .git directory, right? So whenever you go on GitHub and you go to a repository and you go click on this code button, and then you go here to clone. You can clone with different protocols, HTTPS, SSH. You can also actually clone with the Git protocol, which they don't display here. So once I have that on my clipboard, right, I can do git clone and then the URL. So that's going to download the copy into my present working directory. Now I go into here and I can see the .git directory. So git clone is, download and set up my local, repository to point to that remote repository. So you set up all the linkages basically automatically whenever you do git clone. And nowadays, a lot of people are using, instead of the master branch, they're calling it the main branch. And that's simply basically politics, because master has, master slavery, it has negative implications. So people, even though master has been used as a term for many years for like communication, serial communication, master slave, that type of digital communication has been used for many, many years. But nowadays people are trying to, imagine, they don't want to get into the politics of that. So they're doing main branch as their trunk, really. Yeah. So let's see. Don't have that much time, but I'll go over a few of these more intermediate commands. So git checkout. This command, subcommand, is highly overloaded. There's so many different things you can do with Git checkout. And over time, Git has introduced new subcommands to basically subdivide Git checkout into other subcommands. So Git checkout can do a lot of things. What? Oh, sorry. So probably the most common thing that people do with Git checkout is to switch their branch. So a branch is a separate copy of your project. So if I'm here and I list all the branches, I can see here's all these remote branches. I'm not gonna look at those. I've just got here a local branch called main. So if I do git checkout -b, call it new branch. Okay. Now I'm on a new branch. It's a complete copy of my project, and any changes I make on new branch are not going to affect the main branch. Okay, all the commits, track changes, all that, it's on a separate branch. So I can switch the branches with git checkout. That's one thing I can do. I can switch to any branch that I want to. Here, I can go back to main, for example. You can also do git checkout and a commit, SHA. So in Git, every commit is uniquely identified by a 40-character hash code, SHA-1 hash code. And so if I do git checkout and then I put in a hash code like this, I actually only have to enter a few characters that make it unique, right? I don't have to put in the full 40-character. So I do git checkout, the hash code. Now I'm just looking at the project at that particular commit, right? So I'm no longer basically at head. At the head commit, I'm just at some older commit. You can also check out all the changes on some remote branch. You just say git checkout remote/branch. So I can see git checkout origin/master or origin/main, because that's what their naming convention is, etc. If you see this message, you are in a detached head state. Basically, what that's saying is you don't have a local branch that you could commit to. So it wants you to basically create a local branch so that you can start making commits on it. That's what it means with detached head state. And you can also check out tags. So tags in Git are basically a way to attach a version like number or some other identifier to a particular commit. So a lot of people use that for, a particular version. They tag a commit at a version. So like version 1.1.1 or something. And so you can check out the tag and see what the project was like at that particular version. Now, git branch, you can use this subcommand to list all your branches. So whenever you do git branch, it's just going to show you your local branches. As soon as you do -a, now it's going to show you your local and your remote branches, right? So you're only going to download a local copy of your branch if you check it out. So right now I only have 2 local branches, main and new branch. So maybe I want to check out this GHFW remote branch. As soon as I do that, you'll see basically have a local copy. Actually, I don't. Well, I'm just looking at this remote branch, and then I could create a local branch that would point to that remote branch if I wanted to, but git branch -a lists all your local and remote branches. And you can create a branch like this, git branch name, git branch -d. You can delete a branch. Git will complain about the branch if it has changes that you don't have in your current branch. So Git in general tries to prevent you from losing information. Let's see, git push origin branch. I already talked about that. You can delete a remote branch. How do you delete a remote branch? It's like this. You can do git push the remote name and then : and the remote branch like this. Basically, instead of, because this is your local branch name, but because it's empty, it's signifying to Git that you're going to delete this remote branch because you're pushing no local branch to the remote. So you're deleting the remote branch. So git branch -d is for deleting a local branch, and this is for deleting a remote branch. Again, showing that Git is distributed version control system, and you have to specify, are you talking local or remote, basically for everything. Git merge. Git merge is a very common subcommand. You're taking one branch and you're taking all those changes and you're going to put them into another branch. So usually when this happens, a lot of times you get that merge commit. You can do rebasing, which is similar to a merge, but different because you're basically replaying those other commits on top of your current commit, which is similar to a merge, but not quite, because those merge, you get those merge commits. And yeah, so the way you do it is you just type git, say I'm on some branch here, go on a branch like main, I just say git merge, and then I type in a branch name. So whatever branch I want, it could be a local branch, it could be a remote branch, etc. And then it's going to take all those changes in the remote branch and then put them into my local branch, whatever branch I'm on. And you can actually have put in here as many branches as you want. And you will merge all of those branches into your current branch. And I think Linus Torvalds calls this like an octopus merge or whatever. It's basically taking a bunch of branches and all, merging them all in at once to your local in like one merge commit, which is a little bit crazy. So you can merge as many branches as you want actually at once. So you can merge local branches, you can merge remote branches, you can merge tags, etc. So there's a lot of different ways of merging. And like I said, git pull is actually a git fetch and a git merge. So whenever you do git pull, you're actually doing git merge. So a lot of the options that you can pass to git merge, you can pass to git pull. So, and git reset. I don't know how much more I want to go through. This is kind of a lot. Let's see. Basically, git reset is a way to either lose your local changes or reverse your changes. If you do a git reset hard, it's destructive. You lose all your local changes. Your local copy is the exact copy of the remote. You can also do git reset hard with a commit. That means you're going to wipe back your project to some previous commit in the history. All the later commits after that are gone. You can do, say you wanted to unstage a file, you would do git reset head and then the commit, and that's going to unstage all your changes. And you can also just wipe out changes in the particular file with git checkout -- in the file name. I think in newer versions, they've introduced other subcommands to make it the git checkout less confusing on all the different things it can do. But yeah, you can, wipe out changes to a file. You can just unstage a file and things like that. So git reset can do a lot of things. Git stash is just basically a separate list of different changes that you can have. You can have all your local changes, stash them, and then change your branch and then replay them, and stuff like that. So It's just a temporary storage really for local changes. Git tag, I already talked about, it's just a way to add some identifier onto a commit. And git config, there's a lot of different options to git config, a lot of different settings. You can have local, a lot of people don't know, but you can have local configs and you can have global configs. Most people just do the global configs. They put in their username, their email, and that's in the tilde / your home directory git config, but you can actually have local configs that are only local to your project, and that lives in the .git directory. So you could have a different username and email for a particular project, and you can list all your configs. And then a very common thing is to list all the history. That's what you do with git log. Git log by default just shows you the commits. But if you do -p, that means patch basically, and that shows you the actual source code changes in this patch format here. And there's all different ways you can show the git logs, which I don't want to talk about. And git blame, the last thing I'll talk about. Git blame is really awesome because you can see every line of a file who was the last person to modify that file. So you say git blame, and -w just means ignore white space changes. I forgot what -b does. Shows blank, show 100 commits. But anyways, you can git blame and you put in the file name and it's going to show you line 1, Kevin Moore, and this commit on 2018, March 2nd, did this. So it's pretty useful because you can see who exactly, when was this line, changed basically the last time. And most IDEs and editors like Visual Studio Code and JetBrains, they have integrated stuff into their editor, so you can just do the git blame directly in the editor, which is pretty useful. I think Visual Studio Code has like Git Lens plugin, stuff like that. So basically a git blame on the current file. All right, so that's it. That's my presentation. So thanks for coming. Hopes people learn something.
Yeah, thanks.
Appreciate it. Thank you.
Yeah. Are there any questions?
Not a question, something to share though, but on the Git checkout,
Yeah.
you can do branches, but you could also do branches, you can do SHAs.
Right.
You can combine after the branch with a SHA, you can add a file. So
Oh,
you don't
okay.
want all the files.
Yeah.
And I've done that before. Like if I have changes on another branch and I want to pull just like one file
Yeah.
in another branch, you can do that too.
Yeah, you can also do like with the git log, you can pass in files. And so you can see just the log on a particular file, which is useful, like git log, and then you put in a file name. Then that just shows you all the logs related to that file. And I can do -p for the patch option to show me. Yeah. So Git, a lot of times you can pass in files and it just applies your Git command to just that file.
I haven't seen something that I've used, sometimes forgot exactly the command, when you can open up in the editor all your commits, and then you can move them around if you want to reorganize them, or you can squash them and change the messages.
Interactive.
Yeah, let's get rebase-i, and then you pass in the SHA, and then it opens up your editor, and you can basically, re-edit your history, change your history. You can reword commits, you can squash, and of course, whenever you do this, now you get a push force. If you're,
Usually I would use it if it's only my local changes before, pushing it to
right.
I just want to make it pretty, because sometimes you would, like some property file, you were messing with it, along the way, changing it, recommitting it multiple times
Yeah.
till you got the final version that you actually want to make sense. And
Right.
all other changes you want to compile into this one where you say, like,
Right.
okay, that's why configuration kind of, goes and
Yeah.
stuff like
Yeah, you could like basically do your own local squash with get rebase -i. Yeah.
So do you just pick the ones that you want to include in the squash?
Oh, you
Basically.
squash it in between. You put the letters up front.
Yeah.
What you want to do? You want to squash them. You want to
Oh, I
keep
see.
them, or you want to remove, this
Yeah.
from history.
Yeah, the
And then-
instructions are down here. Like, let's see, lines 19. It says, so instead of pick, you change it to like S, for example, or squash, and then that's going to take that commit and just it says meld it into the previous commit. So if you want to squash, you just change this to S, 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 right? And all of these are going to get rolled up into the one above it that says pick, right? Does that make sense?
Yeah, I mean, it's a very good tool to keep your history like kind of, pretty and making sense for everybody.
I'll have to look into that because we have a core app that has a bunch of modules, and I have to build through the CI build in order to get an actual executable file for an iOS app, which means I have in any given story that I'm working on, I may have 25 or 30 commits that all it says is updated my module. Because the only change I made there was updating the module that I'm working on, but I have to actually do a commit there in order for it to go through.
Yeah, I mean, I have this problem with the same thing. Like if you deploy for Jenkins and now you're just messing with the property file, you just change one parameter, you have to commit it for the Jenkins to get the change and deploy it. So yeah, and after you figure out what it needs to be, you have 10 commits, trying to just adjust pieces there. You just want to then kind of clean it up. And
so do you go in here and just squash them all?
it depends. Maybe reward, yes, you could. Yeah, you could mostly squash, keep a couple of them, just reorder. I mean, I would reorder stuff if you create an actual kind of like a baseline again of the project that will be kind of reused. So you want that commit history kind of a pretty like telling you a story what happened, not just like and I forgot to do this. Like that's what I'm doing here. You just push those changes up, in your history, and kind of that's very helpful, kind of, because you don't then like, I forgot something, I need a different commit. How do I fix it? Yeah, just put another commit, move it up, close to whichever commit it should be, and then squash it, and that's it.
Yeah, this is how you would reword a commit that's far back in the history. But like I said before, as soon as you do that, now you got to replay all the later commits, and it's gonna change your history. So
you do it before you share it with somebody else.
Yeah.
It's kind of
as long as it's before PR.
Or then you tell. I mean, like right now I'm in a very small team, like just a couple of guys. So I just tell them heads up, if I do something like that, if I actually have to force push like that.
Go ahead and stop the recording. Anything else that you want to include in this?
Oh.
All right, sweet.